let's see with examples how to draw the poset diagram. So first of all, we need the partial order relation and a set. So for that I am taking this example. Let capital A is containing 5 numbers and the relation on that is less than or equal to, and this relation is definitely reflexive and antisymmetric and transitive. We have already seen it earlier. Therefore this is a partial order relation, and the set along with this partial ordering relation is called as poset. Now how to represent this in terms of the Hussey diagram? So I told you that every node is going to be a point, and we are not going to represent reflexive as well as transitive relations. Other than that, we are going to every other relation will be depicted as an edge, and we are going to see that if there is a pair A comma B, we will put A below and B above it, right? That is how we are going to place it. So since I already know how the diagram looks like, I am directly placing these elements in that order. So how many of them we have? 1, 2, 3, 4, 5, right? And now using this, 1 is less than or equal to 2, which means 1 comma 2 will be related, and 2 comma 3 will be related, and which means 2 comma 3 is an ordered pair which is present in this relation, and 3 comma 4 is there, 4 comma 5 is there. And what are the other ordered pairs that I didn't show is, one is the reflexive, which means 1 comma 1. I am not going to put the loops. Even though I am not going to put the loops, you should understand that they are already present. And also I am not showing transitive relations, which means 1 comma 3 are related, but I am not showing it here. The reason is 1 comma 2 and 2 comma 3 is already there, therefore you can directly imply the transitive. Okay, so if you see this diagram, this particular diagram has a specialty. It is like a chain. The reason is it is a total order relation. So whenever you have a total order relation, always you will see that it is a kind of chain. That is why while discussing about total order relation, we also call it as a chain. The reason is the diagram looks like that. Okay, so let's see one more example. Let us assume that S is a set of sets, set containing sets, and one is 5 and other is A and other is B and other is AB. Okay, so if you look at S, you can even think that S is a power set of A, where A is containing 2 elements A comma B, isn't it? So what does it mean? S is set of all subsets of A, where A is containing 2 elements AB. If you find out all the subsets of AB, then you are going to get 5 A, B and AB, isn't it? Now let us define a poset. Poset should contain a set and a relation on that. Let's say the relation is subset or proper inclusion relation. So what does it mean? If I take this particular set and this particular relation on this set, so which is set inclusion, then I can say that it is a poset. And moreover, why is this a poset is because this relation is reflexive, antisymmetric as well as transitive. You can check that this particular relation on this particular set will be reflexive. Reflexive means every set will be a subset of itself, and antisymmetric. Antisymmetric means if A, B are different, if A is subset of B, then B cannot be subset of A. And transitive means if A is subset of B and B is subset of C, then definitely A is subset of C. So that is how it is definitely partial ordering relation. Now the set along with a partial ordering relation is called as poset. Therefore, since it is a poset, I want to draw the Hussey diagram, and I want to show you how to represent it, right? So again, since I know how the diagram looks like, with experience I am directly trying to place the elements like that. See this. Now 5 I am going to put it at the end or at the bottom level. The reason is 5 will be subset of everything, right? So 5 will be subset of the set A, isn't it? As well as 5 will be subset of the set B. Now these two elements are not related, which means A is not a subset of B as well as B is not a subset of A. In general, when the elements are not related, we try to put them at the same level. That is just a convention, not a rule. If you don't like it, you need not put them at the same level. You can try to place it a level above. That is up to you. And now if you have the next AB, right, So AB, you can have the relation like this. The reason is A is a subset of AB and B is a subset of AB. Got it? So this is how you can represent the Hussey diagrams. So let's see some more examples. With that you will understand this better. Now let's see this example. Let us say A is having these numbers 1, 2, 3, 9, 6, 18. Okay, 1, 2, 3, 6, 9, 18. And now we are defining a relation divides. So A is a set and the divides is a relation on that, and you can check that this divides is definitely a partial ordering relation on the set A. You can check that, you can verify it. Okay, so now I'll try to draw the diagram. So where to start with? It is always better that you take the least element and you put it in the middle. So what is least element? That we shall discuss again. Here my intention is just to show you how to draw the diagrams. Now 1 divides 2, isn't it? And similarly 1 divides 3, and similarly 2 divides 6, as well as 3 divides 6, and 3 divides 9, but 2 doesn't divide 9, that is why I am not putting it, and 6 and 9 both divides 18. Right? So with experience it will be easy. You might now think that how did I get exactly this diagram? So that is with experience. With experience, if you keep on doing more and more examples, you will get it how to do it. Okay, don't worry about it now. Now see this: 1, 2, 3, 5, 6, 10, 15, 30. So all these numbers are nothing but divisors of 30. So if you take 30 and if you find out all the divisors, you will get this set. Now on this set, if I define the relation divides, then that relation is going to be again partial ordering relation, right? So since it is a partial ordering relation, we should be able to put it in the diagram, right? Poset diagram. I'll just try to put it. Again, with just experience, I'm doing it directly. Now 1 will be in the ending. 1 divides 2, as well as 1 divides 3. Why am I putting 2 and 3 in the same level? Because 2 doesn't divide 3 or 3 doesn't divide 2, that is why. And then 5. So 5 also I am putting in the same level because these 3 elements are not related. Therefore, I need not put them in the next level. If let us say if 3 is divisible by 2, then it would make sense if I put it in the above, in the level higher than 2, and then put an edge. But since they are not related in any way, it is better that you don't put them in different levels. Put them in the same level. And what about 6? 6 I can put it here. So why am I putting 6 here? Because 2 divides 6 as well as 3 divides 6. That is the reason I am putting 6 there. And what about 10? Should I put in the same level or in the above? So I can put it in, okay, first of all 10. Should I put 10 in this level or this level or this level? So this level I cannot put 10. The reason is 2 divides 10, therefore it has to be above it, and as well as 5 divides 10, it has to be above it. Now can I put it in this level? Yes, in this level I can put 10 because 6 is not related to 10. So let me put 10 here. Alright, now 2 divides 10 as well as 5 divides 10. Got it? Next one is 15. So should I put the 15 in this level? I cannot put it in this level because 5 divides 15 and 3 divides 15. Can I put it in this level? Yes, because 6 does not divide 15 or 10 does not divide 15, which means 6, 10 and 15 are no way related. That is why I put them in the same level. So 15, I am just putting it there. Now what are the things that divide? 3 divides it as well as 5 divides it, right? And the next one is 30. Should I put 30 in the same level? No. The reason is 6 divides it, 10 divides it, and 15 divides it. Therefore, there has to be an edge. If there has to be an edge, it should always be from the lower level to the upper level. So let me put 30 here. 6, 10 and 15. Got it? Because 6 divides, 10 divides and 15 divides 30. Now see this. Again we have a set of elements 1, 2, 3, 4, 6, 9, and then we are having a relation on that set which is divides. So again this is partial ordering relation. You can find out it is reflexive, antisymmetric as well as transitive. So let me see how to put it in terms of Hussey diagram. So we are going to put 1 in the base level or in the bottom, and then 1 divides 2 definitely. And what about 3? 1 divides 3 and 2. 2 and 3 are not related. Therefore, let me put 2 and 3 in the same level. And what about 4? I cannot put 4 in the same level The reason is 2 divides 4. So let me put 4 here. The reason is 2 divides 4. And what about 6? I cannot put 6 in the same level because 2 and 3 divide 6, but then 4 doesn't divide 6 or 6 doesn't divide 4. Therefore I can put 6 here, right? 2 and 3. And what about 9? So you can put 9. You cannot put in the same level, right? But you can put 9 here. The reason you are putting 9 here is because 3 divides it, right? So just check this. So 1, 2, how many are there? 6. Yes, 6 elements. Got it? So this is how you can represent this in the poset diagram.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into university is better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building. And then LOR guidance. And GRE and English test assistance. And education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.